Good evening everyone, myself Gautam Sharma. I welcome you all in the Sapience education. So today I am going to discuss about the hydrodynamics of the fluid in a motion. So as you know that a fluid will always be in a motion or in a rest, but I will discuss about fluid in a motion, and this come under the category of a hydrodynamic fluid, right? And fluid has several types of motion, so we will discuss each and every types of motion step by step. Okay. Now, what is fluid dynamics? The study of a fluid at a motion is known as fluid dynamics. Okay, fluid statics, the study of motion, study of fluid at a rest. But now I am discussing about the fluid dynamics. So there are several types of a fluid flow. So definitely there are different type of flow. Fluid may be very smooth, it may be turbulent, it may be anomalously, it may be unsteady, it may be steady. So what are the type of study we need to study? Let us see. So first type of fluid flow is your steady flow. What is steady flow? What is steady flow, right? What is steady flow? The flow at which the fluid characteristics like pressure, density, velocity at a particular point do not change with the time. For example, if you consider this fluid before, see here earlier, if the pressure is P1, velocity is V1, density is ρ1, and all these properties are constant. After some time also the same thing, that is pressure, velocity, density, all will be same. Okay, all will be same. So from here structure, can you imagine this same speed, same properties are there after some time. So it is not changing with the time. It is not changing with the time, right? So if it is not changing with the time, then it is known as steady flow. Flow which is not changing with the time is known as steady flow, right? Now I am talking about unsteady flow. What is unsteady flow? See here, unsteady flow is what? If the velocity, pressure, density at a point in which the flow changes with the time, then it is called an unsteady flow. For example, pressure is now here, earlier it was 100 Pascal. After some time you have seen that it is your 50 Pascal. Some density's value is 100. Now its density become 20. Likewise, if something is changing, then you this type of characteristics are changing, then this type of flow is known as unsteady flow. From diagram you can understood. See the length of the flow, length of the arrow is smaller. It means that some properties are changing. So this is what known as unsteady flow. This is known as unsteady flow. Okay. Now third is your streamline flow. What is streamline flow? So from figure you can understood. So before that we need to understand the definition. The flow in which each particle of a liquid passing through a point travels along same path with the same velocity as the preceding particle passes through that point. So do you understand this? See, for example, no matter how much speed it has at this point, but when we talk about at a point P, whatever speed will be earlier, but here it has some fixed velocity, that is 10 meter per second. Every particle coming from anywhere, it has some great speed also. It may have a more than 10, it may have less than 10, but as soon as it reaches at a point P, so what happens? Its speed become constant. Either you can take any point Q, so its speed become constant. Either you will take at a point R. So if R has now 50 meter per second, so after some time also all the particles coming from this will attain the same velocity at this point. Okay, and the direction of velocity is same. So that type of flow is known as streamline. So streamline is a path such that tangent to it at any point give the direction of fluid flow. So what is streamline? Streamline flow is, you have understood. See, this is a streamline flow where every point, if you will take any point, then the velocity at this point at every time will be same. Velocity of any fluid coming, no matter how much earlier it has speed, but now when it reaches at a point P, and point P has a 10 meter per second velocity, then it will become 10 meter per second. Now if Q has one particle has velocity 20 meter per second, and earlier it has a 10 meter per second here at a P, so when it comes to PQ, so what will happen? Its speed will become 20 meter per second. Got it? So this is what all about streamline flow. And the streamline is the line at which if you draw the tangent, so tangent will give you the direction of velocity, and this is known as streamline. This is known as streamline. See, this line is known as streamline. Okay, this line is known as streamline because at every point tangent will give you the direction of a velocity of the fluid flow. So I hope you have understood this streamline flow. Now what is laminar flow? Very important, laminar flow. So before that, before going to the drawing, so at first you should read this. It is a flow in which the fluid particle moves along well-defined streamline which are straight and parallel. Which are straight and parallel. See the all particles. I have taken duck. So all duck have same speed and they are moving with the same parallel speed. Got it? Same parallel line. They are moving with the same parallel line. They are not changing parallelity to each other. And velocity at different point may have different magnitude, but the direction of particle are parallel. See, now you have seen that velocity is now in this direction 10 meter per second. Now here you see that velocity at this point is 10 meter per second, but in another direction. Okay, so velocity may be changing, but the particle, the parallelity or the two particles have the same distance of separation, or all will follow the same parallel line. Got it? All will follow the same parallel line. So from figure you can understood. Here also same parallel line. Here also same parallel line. If they will bend, so they will bend equally. So that's why this type of flow is known as laminar flow. Got it? Got it? I hope you have understood now. Laminar flow. And if it does not follow this situation, then that type of flow is known as turbulent flow. See here, turbulent flow. It is the irregular flow. See here, irregular. We don't know the fixed movement of the water. So it is an irregular flow which particle can move in a zigzag way, due to which eddies formation. Eddies, you know, eddies means what happen when water is coming with this. Water is coming with single direction like this. Water is coming, right? Suddenly, what happen? It move backward due to stones obstacle like this. So these type of things we can say that eddies. Okay, so eddies formation take place and which are also responsible for high energy loss. So whenever any flow is colliding with the stones and all, an eddy will be formed, and due to this eddy, what will happen? There will be a loss of energy. There will be a loss of energy. Got it? There will be loss of energy. I hope you have understood now. Now one more important thing, what is critical velocity? The critical velocity is that velocity of a liquid flow up to which its flow is steady. See here, when we talk about this critical velocity, see here, suppose it has laminar, say laminar, okay, it has a laminar flow, okay, and it has a steady flow, you can say, up to which there was a steady flow. But as soon as after this velocity, see here, before that velocity, it has velocity 10 meter per second, 12 meter per second, 13 meter per second, 15 meter per second. As soon as velocity become 20 meter per second, so what happened? After that, what happened? The flow become automatically turbulent. You know that when the fluid's speed become very high, then it will become turbulent. It won't be in a laminar flow or streamline flow. So when this happens, so what will happen? So the velocity at which this change happens from steady to unsteady, laminar to turbulent, then this type of situation is known as critical velocity. So this is all about our all type of velocity of the fluid is there. So if you want more videos in this topic, or definitely I am going to switch for next topic also, Bernoulli's theorem and all. So these are the basic definitions. So go through this, and I have given class notes. So go through that also, and be connected. Please subscribe this channel so that you will get regular regular video. Okay, so thank you for joining my classes.